Well, this morning, as I promised, I'm going to talk about the sun. So I have a lot to say. Maybe I should get started. But the context of speaking about 17th century is very real in the sense of people are always talking about climate change, global warming, causing all kinds of chaos in the climate system. Have more hurricanes, more, polar bear dying off, and so on and so forth. But I want to point out that it is the cold that is going to cause more problem than the warmth. That's for sure. In terms of human mortality, it's a well-known fact that cold kills more than heat in some sense. Well, there are all kinds of statistics. A paper just published last week actually in famous Lancet magazine saying that it's actually, for the statistic in some 500, 600 cities in Europe that you collected the statistics, is basically 20-to-1 ratio, which means, if you have 1,000 people dying during the heat, there are 20,000 at least died during the cold. So that's a fact. That's the context of 17th century, because 17th century is a very cold time. It's a very special period in the sun's activity. It's called the Maunder minimum, and we will go about more details. So first we start with a quiz. You don't need to answer this, but take a look at this. Which part of the sun here that looks very unnatural? Well, it's right here. That image, that is not sunspot, by the way, right? That's a quiz. It turns out to be the space station passing in front. This has been puzzled all the greats for a long time. Johannes Kepler. You all know about Johannes Kepler? Kepler law? Nobody know what Kepler is? Oh, you have to study, sorry. Kepler used to think that sunspot was not sunspot at all. Galileo was the one that figured out, plus a few other people. Kepler, despite his brilliance in mathematics, he thought that it was just planet passing by like Venus, Mercury and things like that. This is just one example from modern time. You see, this is tracking of the space station passing by the sun. But there are sunspot occurs. You can see some sunspot around there too. Anyway, the theme of the talk is, there are three of them. One is about solar Maunder minimum, which is the sun is extremely weak. And that leads to the condition, in my humble opinion, to the coldness and all these other conditions that we see. And then overall, you have this very, very serious socio-political turmoil on planet Earth, okay? And we'll show some evidence for that. But then the main thing I want to get across here is that to study climate system, to try to understand everything, you really have to cover very broad range of understanding. You not only have to understand history, you have to know about the sun, you have to know sun, earth, and other planets' orbits, including the moon. You have to know meteorology, you have to know climate, you have to know, in fact, I'm going to introduce something very surprising. People thought that it's all unrelated. In fact, volcanoes and earthquakes are involved also in this condition that we have in the 17th century. So let's start with study of the sunspot activities. As we know that the telescope was invented about 1607, 08, that sort of time, 1609. By 1609, this guy by the name of Galileo Galilei already started pointing his telescope to various objects. I think his first object is obviously the moon. Then he go to the Galilean satellite, the Jupiter satellite. This is the example of the moon, that he pointed to the moon. But Galileo is such a interesting and clear thinker in the sense, is that he says that science cannot be just a belief. Science ought to be demonstrable. So he actually conducted such experiment. Let everybody look through the telescope. If you don't believe that the surface of the moon look like that, so take a look yourself, right? So science is like that. It has to be replicable. It has to be really fact-based and have to be really not hiding your data. Like yesterday, you see the thermometer data, you couldn't get it from those guys. It's just crazy. Anyway, here's one of the Galileo's product. He actually observed the sun. This is about 3 months of more data. Somebody animated this and make this. You notice how smart he is actually? He got it so accurate that the sun and the earth, there is a tilted angle about 7 degrees or so. You can see the rotation axis is this way. Do you guys see it? That's basically how good his observation is. So science is about good observation. How you observe the natural world is very, very important. Here's the modern way of looking at sunspot, right? Sunspot is extremely dynamical, by the way. That's how it appears on the sun. And the thing that we want to talk about is a period called the Maunder minimum, from 1645 to 1715 or so, okay? And it was named after this husband and wife team, Walter Maunder and Annie Maunder from England. And they are extreme dedicated sun observer, because he was assigned to study and take photo of the sun. He worked from 1874 until 1928, until the day he died. He was capturing the daily image of the sun without fail, this guy, Walter Maunder. So no wonder I was inspired. Before all my kids were born, I spent 1 year of my weekend, 52 weeks, go to the Harvard Library and then actually produce a little book like this called The Maunder Minimum, to try to introduce this concept of Maunder Minimum, how weird it is, how is it connected to the Earth climate system. So I produced this little book. And then here's what Maunder Minimum looked like. It's actually from that period, right? As you see, the first data point is essentially Galileo Galilei, right? From 1610 or so, all the way up to present time, right? And then, but you can see sunspot come and go. Did you see the regular thing? Those are called the 11-year sunspot cycle, right? All these cycles, because it keep come and go, come and go. But there's a period. The sun have no spot at all, essentially disappear. But if you plotted the location of where the spot is, okay, from the latitude of 90 degrees south to 90 degrees north, you can see in the middle, in the equator, there actually very few sunspot is formed. But in the Maunder Minimum period, look at that. It's very unusual compared to actually the modern time. The bottom part is actually the modern time, right? About 2000, 20th century. You can see it look like a butterfly wings. One of my colleagues from Paris Observatoire de Paris described that during the Maunder Minimum from 1645 to 1715, there is a broken butterfly wings, okay? It's very poetic of describing this. And then with my colleagues, we've been working very hard. By the way, you don't have sunspot not because nobody was observing. During this period, actually we know that 80% to 90% of the time that the sun was actually observed and there were no spot. In fact, the French Observatoire de Paris, the director, Pierre Cassini, they were actually observing the sun. They say that, what's going on? Why there's no sunspot? Galileo must be talking trash. I mean, he was telling us there was a lot of sunspot. Because Galileo watched around 1610 to 1640, there was a lot of sunspot. And then all of a sudden, 1645, not much of a sunspot. But me and my colleague, Victor Velasco Herrera from University of Mexico, and the greatest sunspot historian of the world, Douglas Hoyt, he's living in West Virginia, and we actually combined to produce a work to come up with a daily sunspot observation, data. So we're trying to deduce what it is. There's a lot of mathematics involved, but that's what the 1645 to 17 period it's about. It's basically the time of Louis XIV, the Sun King. He ruled when he was very, very young, like a baby. And then the coincidence of this is I want to show the Hall of Mirror in the Versailles in Paris. If anybody got a chance to go to Paris, you ought to go visit this place. But the mirror that was used for this Hall of Glass was actually the same telescope mirror that I use with some of my colleagues to study the sun-like star at Mount Wilson Observatory, the famous observatory discovered the Big Bang and Albert Einstein, so on and so forth. But anyway, this is actually another aspect of the sun's activity. Sun is a giant, enormous fireball, right? Fully magnetized and all kinds of things. Another very interesting phenomenon during this period is actually because of the particular condition of the cold and the wetness and the sunshine condition in the northern Alps of Italy, you can actually have a very long winter and cool summer, and they produce this wood that grow very slowly and very, very even growth and very, very dense. High quality sound, which produce among the best, according to some expert, because my kids, Ben and Emily, started to play violins. I was very interested in this phenomenon. So they produced the best violin called the Stradivari, right? And this is one of the nice aspects of having this particular Maunder Minimum in some sense. Now I'm going to get into USA, right? The setting, this is actually an eclipse, a partial eclipse. And then we have our Statue of Liberty there. So yes, indeed, I promise that I'm going to show you this exciting rediscovery, right, of first sunspot drawing in America. But before that, let's quickly look at how sun is being perceived in ancient China. For example, in the Ming Dynasty, that this particular emperor is very fond of observing the sun. He doesn't have telescope yet, but sometimes the sunspot is so big, he even used a Chinese brush. He make a sunspot like that. And then he's so famous, some of the last Ming Dynasty, that even his chair was auctioned in England someday for $15 million. But I want to say that America has our own sun chair too. I'm sure some of you who study the Constitution would know that there is such a sun chair in the Independence Hall, right? I visited there with all my kids for the vacation with my wife, and here Emily was there. You guys know where the sun chair is? Right there. That's where George Washington sat there for 3 months during that meeting. And I want to read a quote that is very famous, immortalized by Benjamin Franklin. And this is actually an account from James Madison himself, which reads something like this. I hope my pronunciation will work. While the last member was signing it, the Constitution, of course, Doc Franklin, looking towards the president's chair, at the back of which a rising sun happened to be painted, observed to a few members near him that painters found it difficult to distinguish in their arts a rising from a setting sun. I have said he, often and often in the course of the session, and the vicissitude of my hope and fears as to its issue. Look at that behind the president without being able to tell whether it was rising or setting. But now, at length, I have the happiness to know that it is a rising and not a setting sun. That's the beginning of America, isn't it, right? So I want to say that, please, we will never, never auction this particular chair for $15 million. This is American legacy, right? Anyway, so the story here starts like that, right? We have a sun chair. So the sun history is fairly long. The first guy I want to introduce is actually a botanist named Humphrey Marshall. You may boo, of course, because he's one of the famous botanists that all his seeds is planted in King George III's garden, and then Louis XVI, so on and so forth. He celebrated the 300 years anniversary of his birth. Okay, so this guy is quite a good guy. He's a botanist. So what does botanist do during winter? Nothing better to do, so he used telescope, observed the sun. That's what he did. He actually observed the sun around a few times, of course, during most of the winter. This is one of the letters he wrote to Ben Franklin, essentially trying to say how he observed the sun. He drew a circle, and he has some painting. And then Ben Franklin, being a guy that actually was ambassador, I think, in England, helped him. By the way, this is how Humphrey Marshall, no one knows how he looks like. This is just a model. The painter is Adrian Martinez. He's in Pennsylvania somewhere. And the telescope and the microscope were the stuff that Benjamin brought back for him from England while he was in London. But here is actually what Benjamin Franklin had done for him. He presented his sunspot results, published at the Royal Society. And then the thing that puzzled me when I read this particular paper was actually the line there, who says that there's the figures of this thing. In fact, people thought, one of my colleagues from Spain actually thought that this particular drawing was lost already for a long time. So I tried to trace it. I couldn't find it until today, of course. But this particular person, Adrian Martinez, say that his recollection is that he has seen it. It does exist. So this is one of my failures. I thought I could find it in 2021. So 2 years later, we still haven't I haven't seen it myself, but Adrian Martinez has seen it, right? He says it's disappointing, but I think this will be very important to trace it down. So for some of you kids, you want to do the work, go do the work, right? I'm done. But I want to find another more exciting one. The more exciting one is basically my good friend Douglas Hoy. As I told you, he's the premier sunspot historian. He told me there are 3 more. One is by Brattle in Boston, and then Robbie, 1722. But the one by John Winthrop, Professor John Winthrop of Harvard University, back then it was still a Christian university, was observed that in 1739. But he said, no drawing that I can recall. So I want to say, Douglas Hoy, I deeply admire him and respect him. But if I were to follow his instinct, I wouldn't look for it, isn't it, right? But for me, never, 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 ever, ever give up. Just keep looking. So I've essentially recovered this, right? So I think dark cloud is slightly mistaken. I think I used the right word. So it has been discovered in that sense. So I will show you. In fact, I showed it last week in Tucson. This is the second time. No one in the world has ever seen this in some sense. So, well, just to tell you that Harvard, it is the premier institution for studying the sun. This is actually a photograph, among the first photographs of the sun taken in 1873. The rest of the outside is actually some sketches by a famous, entomologist. These are people who study insects. He brought in actually some kind of spot butterfly from Europe. His name is Leopold Trouvelot. He worked for Harvard. So This is among the very early one. In fact, it's very rare to have such a high quality picture around. So this is it, John Winthrop. He lived from 1714 to 1779. So now, but we're talking about the 1739 observation. I'll provide in more detail in a minute to describe this particular interesting observation. So this is how John Winthrop looked like. By the way, he's from a very famous family tree, right? His great-great-grandfather is actually Governor John Winthrop of Massachusetts. And then, of course, they're a bunch of cousins, basically Connecticut, the whole New England is basically this whole Winthrop family. But he's highly educated. He's among the first mathematician, astronomer, and physicist that actually being accepted by the rest of the world in the sense that recognized by the Royal Society in England. Remember, England have Newton. No one can replace Newton in that sense. But we, America, have our own John Winthrop. He realized about phenomenon, about earthquake in Lisbon, so on and so forth. But here is his actually details observation. You see, around April 19, he was at the other side of Cambridge, the river, the Charles River. He's at the other side. And then the sunspot was so big. He was passing by, as he can describe, he saw it. So he couldn't wait till he get back to this side where he has the telescope. So by Thursday he saw that. Friday he came back to Cambridge. You see, he started watching, using the telescope from 6 a.m. until, evening, the sunset. And then he was describing this image on April 20th. That's where he put this drawing down, right? And then, so patiently, April 21st, cloudy, what can you do? Cannot see the sun, right? Nothing you can do about it. So he waited for April 22nd, doing things like that. By the way, Galileo Galilei is one of those, another brilliant guy also, when he was doing it. Cloudy day, cannot observe, but they wait. The point is that, not give up, do it. Wait for the next thing, see where the sunspot has moved. That's why he realized that this thing actually comes with the whole sun. If it were to be like a satellite of Venus, they pass by very quickly, so it disappears. So it cannot belong to the sun itself. So that's basically fundamental about thinking clearly and all that stuff, right? I think the sun is smiling today. All right, so I'm going to talk about now the history and the socio-political problem during this particular period. It's really coincide with this particular minimum period. There's a book written by Ohio State University. This is actually an English man. He actually lives in Ohio now, Jeffrey Parker. He wrote this book called The Global Crisis during 17th century. I sort of copying him, but I'm working independently from any of them because he doesn't know too much about climate or the sun and so on and so forth. But this is one of his famous books that published, I think, by Yale University Press. Okay, he wrote this book, but I want to tell you that we know a lot about the climate and sun and so on and so forth. Overall, that particular period of 17th century is very cold and it's also wet. The reason why the 17th century is very interesting is that it's actually the coldest period with the largest glacier mass. Like you have a lot called Little Ice Age, where of the last 8,000 years, basically. And in England, you have a phenomenon called the frost fair, where the Thames River was completely frozen over. So there were at least 3-4 times periods from 1608, 1621, 1677, 1684. The well-known frost fair is known that it's completely frozen over, so you can have activity like this. So these are all famous painting in some sense that people were describing how cold that period was, including the Thames period. Another social phenomenon is that during the 17th century, guess what? Remember, Europe never know about spices, don't have sugar, don't have all this stuff. 17th century, all this thing beginning to come in. We got coffee house. The first coffee house found in Oxford University around there, right? I love coffee, that's why I have to investigate this a bit. Anyway, 17th century is also well known in the sense of white Irish slave. Since we live in Salem, Massachusetts, I couldn't help but showing this. Because the last person that was killed at the witch trial was Anne Glover. She and her husband were actually white slaves. Here, I'm not trying to create a fight between the Catholic and Protestant. All I know is that they were really treated as a slave. They were sent to Barbados, right? And then the husband was killed. But eventually, she was also hanged because in some sense that she was not able to say the Lord's Prayer in English. She would say it in Gaelic. So in some sense, this is quite historic. I think the plaque is down somewhere in Boston. Hell would probably know where it is. Anyway, during this particular 17th century, indeed, it is the coldest time in 8,000 years. Okay, so that's unusual. And then here's how the condition, why is it cold? If you look at the graph, by the way, I told you that please ask me for the graph so you can study it. and it takes a long time to collect this information, by the way. The upper part tells you that the ice has been accumulated a lot. This is the largest glacier size. This is all glacier size in Europe, in Switzerland. The Swiss study the glacier a lot. And during those particular period, there were churches that built down the hill of all this glacier was moving. People were really praying in the church. Please don't let the ice come. Eventually the ice grows so big that the glacier mass started to grow down and cover up the whole church at that time. That's how cold it was, okay? And then modern time, you can see there's less glacial extension from that picture, right? Yeah. But it just tells you that it's not global warming. It's just basically that we come from a period in which it's very cold, and then the sun started to warm up, and then it started to go away. Basically, that's all it is. And they keep saying that it's having to do with CO2, but it's not CO2. Anyway, in cave of Beijing, you can study that it's cold, but in that time, it was also a drought condition actually in Beijing, okay? And here's telling you that in northern China, northeast China is a bit wetter during that period, and it's drier in southern China. It's telling you that the complication of not only temperature, hydrology, water. We are water sphere, hydrosphere, right? It's very important to know where the water are. You know, sometimes you have drought, sometimes you have flooding, right? Now flooding, they keep saying that it's global warming. It had nothing to do with it. And then another condition is actually during this time, you even have cannibalism. This is data collected from China, and then war, of course. That's the transition. For that period, it's actually transition between the Ming dynasty to the Qing dynasty. During that upheaval time, people were starving and stuff in China, and cannibalism too. And then I actually published a newspaper op-ed when I went to Hong Kong University. I was invited to give a speech there, but I was pointing out this particular condition. I mainly want to point to you that during that period, it was also the strongest, from 1660 to 1680, it was the strongest typhoon in Guangdong, southern China province. There are documented evidence like this from a lot of study called the paleoclimate study. People are studying those things, right, at that time. So I published a thing like this just to try to tell people that no, it's the cold period that we should worry more about than the warm period in some sense, because people thrive. All the life system, the biological system. Remember, we ought to not only consider human. I mean, all the biological systems really thrive during a warmer period. And then here's an example from Korea. Korea, actually, they keep a very good chronicle. They keep a long history. Look at that period. It's actually very, very strong tsunami period. You all know about tsunami, right? It's basically the ocean tidal wave, bringing wave that is 30 foot tall or even taller, and then swarm the whole area. So typhoon, and that is also documented in the Korean Peninsula during the Maunder minimum period. So it shows you how significant when the sun gets weak, meaning the sun is dimmer, emitting a lot less energy than what it is today. So that's why it's causing some of this particular condition. And then here you can even catch it in Japan, right? During all the bar there was basically the Maunder minimum period. It shows you that it's actually very exceptional. You look, there's a medieval warm period in Japan, clearly documented. It's warm about year 1000 AD. And then from 17th century, basically it was very, very cold, and then it warmed up again. That's basically what it is. And here's another study based on tree rings. Japan, in southern Japan, they have a very, Yakushima Island has a very good cedar tree that actually very long lived. They are up to 2,000 years for this particular series. They were able to study. Look at that. The Maunder minimum period is indeed one of the coldest time ever recorded in that particular record, isn't it? And then maybe I shouldn't say this. It can be a bit controversial. When you don't have Christianity and all that, you tend to do different things. When you have population growing in Japan, look at what the Japanese people are thinking about. They actually are killing their babies off because too many mouths to feed. Conditions were harsh. You cannot grow enough food. So you even consider killing babies in that sense. So it is one of those tragic things when you have cold period, isn't it, right? They somehow think that it's logical or it's even reasonable to try to kill babies in that sense. But this is brought on by another, never mind Planned Parenthood nonsense. Anyway, I want to say the last part now. We know that the sun and the orbits are doing all kinds of things. That's another aspect of this that actually, to make the story full, is basically that why is it that 17th century was so exceptional? The exceptional is things that we do not know yet, okay? That I want to tell you is mostly related to volcanology and earthquake. That I want to show you some evidence. Because most people just treat them as separate subject, you know. Oh, weather is weather, climate is climate. Until today, United Nations or the World Meteorological Organization couldn't tell you what is the climate, what is the weather. They don't know actually. They created something called arbitrary kind of rules. Wow, the experts say this, the experts say that. They say that, they essentially give you the definition. They say climate is just the average, 30 years average of the weather. I ask, says who? You all know, right? Because very important to be not afraid of this thing. When they say those statements, you should raise your hand. Who? Why 30 years? Can you explain why not 100 years? Why not 50 years? Please explain to us. You cannot just declaratively making a statement. That is not science actually. That is anti-science, put it that way. So, to study climate, what do you think you need to study? Anybody want to read this out, please? An understanding of climate requires an amalgamation of mathematics, astronomy, solar physics, geology, geochronology, geochemistry, sedimentology, tectonic, paleontology, paleoecology, glaciology, climatology, meteorology, oceanography, ecology, archaeology, and history. I just hinted to you, you need to know volcanology, you need to know the tectonic physics, isn't it? And 17th century is well known. This is one of the largest eruptions that happened on January of 2022 in southwest, in Hunga area. It's South Pacific, you know, huge. You know how large this eruption is? The material that is spilled out is actually under volcano, underwater. This thing is under few thousand meters or 6,000 feet of water. It blow up. It go all the way to, I don't know, 60 miles up in the atmosphere. You can detect the output. Look at how strong this is. This is really nature. This is God at his most supreme in that sense, right? There's no way that the carbon dioxide is going to overwhelm such a forces, isn't it? Just think about it. But in my way of thinking about it, this is all connected, this whole picture, this Sun-Earth orbital business, you know, Sun, Earth, planet, and Moon, and so on and so forth. And the famous eruption is happened in Indonesia. It's a place called Krakatoa. Actually, I happened to see this one from when I was in Jakarta. Again, I don't have money, so when people invite me to do, I get to do this sightseeing a little bit. So we see that from the far. And Krakatoa is becoming active again. Okay, in 2018, start erupting. Okay, but what happened during 17th century, right? During Mount minimum time. Indeed, you can actually study because the ashes and some of the burnt product, you can actually detect them in the ice core in Antarctica and in Greenland. You can study that. You drill the ice core, you try to get the time right, and then you can study all these ashes and they are trapped there. So there are evidence of that. So during the Mount Minimum, there are a lot of well-known ones. From 1609 one is very well-known. Huayputina is in Peru. But they found a new one, two new ones actually. By the way, when scientists say that they have discovered this is a volcanic eruption, guess what they do? They have to go to find the physical location. It's called the caldera. They actually found these two, 1640 and 1641. Immediately, one of them is in Hokkaido Island, okay, 1641, and the other one is actually in Philippines. They actually found the area where this thing is. So that's basically what science is all about. You cannot just make claim, you know, you talk nonsense. You have to go look for it. And these people are working very hard to find some of this. So there are some science going on, but unfortunately it's all corrupted in some sense. And this requires some funding, of course. When you require funding, it's already all games are off. I've been in that business for so long now, I kind of don't want to take money to do this kind of thing. It's a bit bad. Anyway, well, I want to tell you that yes, all these are connected. They are connected through basically Earth and Moon going around the Sun. That's basically what it is, seasonality, basically. And this is one of the most surprising things. When I saw this, actually, this is a paper published in 2004, by the way, from a group from University of Cambridge. These volcanologists, they actually take the whole Smithsonian Institution catalog for almost 300, 400 years of catalog of documented volcanic eruption, and ask a very simple question in science. Please remember, the most simple question, if you can answer, is the most beautiful one. They ask, of this 300 years, and then let's see whether we know where the timing, what month this thing got erupted. Can we ask, that is there a pattern to this? They actually, surprisingly, if you do that January, you know, for 12 months, it's very easy, right? What month is born, we put on it. And actually, there's a seasonality to it, okay? It's basically from January to July, it's a lot more eruption. And then from July to December, it's less eruption. And overlay there, I draw a curve. We put a curve that I label seasonal sea level. this is actually related to the sea level. And the amount there is very small, 20 millimeter, that's about an inch. Please remember, number is very important. It's only an inch. And do you want to know how large the changes in sea level for basically the little ice age, the monominimum period versus this? Those are 400 to 500. That's almost 2 feet, millimeter, right? 2 feet. It's huge because the loading of the ocean, remember what they're loading, they put pressure on the crustal and the surface of the thing. That's basically what it is. I'm trying to explain to you from July to January, when your sea level is actually high, you press down, so you squeeze the system to the mantle and all this stuff is kind of quiet. And then when you release, relaxation, the sea level go down, it started to do this. That's basically is possible through this mechanism. In fact, there's a lot of details. You have to study all kinds of things about solid earth and so on and so forth. Here's just an example to tell you that from wonder minimum to basically warm period, like right now or during the medieval warm period, you clearly can see very large changes in the sea level of the order of 2 feet. Okay, 400 to 500 millimeter. So that's it. Can we find anything seasonal modulation or earthquake? Yes, we can. It's one of those topics that people just neglect and don't look into it. I happen to be very curious and looking for all kinds of things. That's why I think I can find the first sunspot drawing of America. You have to be curious. I don't know, I'm just naturally curious. But you look at this. In Hokkaido, they found, actually it's true, large earthquake. They depend on the snow load. So in the summer, you don't have much of the thing, then it releases. Then you got to have more activity, more earthquake, right? When there's no snow during summer. And then winter, of course, maximum, when snow is loading, pressing it down. So don't allow the eruption to occur in some sense. And then this is one of the very difficult subjects. The graph may not make sense to you, but you're trying to study a pattern of what they call deep focus earthquake. These are earthquakes that occur 500 kilometers down, okay? 300 miles down, let's say, something like that, right? Down in the earth, you know, the surface, the crust. And then they found this one for magnitude 3 or 7 and larger. They actually was able to find seasonal modulation. This is the best group of earthquake study from actually Southern California. This group is actually California Institute of Technology. One of the good schools that I almost want to study there. But anyway, let me finish. So 3 conclusions, right? Maunder minimum is strong and robust. It's not because no one was watching. Clearly that the sun was very well observed. People were observing. In fact, the Observatoire de Paris director was Cassini. Cassini was actually saying, what is wrong? What is happening? But today now we fully understand actually what happened, right? Essentially the sun went into this period where it went to some kind of hibernation because the magnetic activity becoming very weak, and then sunspots started to disappear somehow, you know? Not completely disappear, but it's there, but it's still very, very low amount. And then during that period, the weather is significantly changed. You have a very seriously cold and wetness condition. By the way, cold is also not so bad. You see that for the slow growth region in northern Alps of Italy, you can produce this quality Guarneri or Stradivari kind of a violin, right? That is actually high quality in tonality and all that, very dense growth. And then finally, I want to encourage everybody is that science is an open question. It's like studying the mind of God in some sense, isn't it, right? And this is a very beautiful thing and one ought to study. To put it all in context, I often say that warm will not be the enemy of the humankind, you know, it's the cold. So what about the future? We all know that Maunder minimum, it is a challenge for what you call climate dynamics. In fact, with some of my colleagues from Argentina, Sionso and another colleague of mine, Victor Velasco Carrera, we were able to produce a curve like this to study the history of how the sun's incoming radiation would do. We actually now forecast. Remember, I don't randomly make forecasts. It really takes me a long time, 32 years exactly, to do things like this. Because, you know, as a scientist, you never grow. You always like immature. But I'm confident now that this is reasonable work. So we actually think that in the next, well, we are in it now, more or less. We are gradually into these things. So it's a good test against the global warming hypothesis. By the way, it's not a hypothesis because they didn't turn that into a hypothesis, right? They turned into some kind of wishy-washy stuff. Every time there's something, they will change another point of view. They just keep correcting themselves. Here is a real forecast. We make this forecast, we'll wait for it. If it's wrong, I'm wrong. But I'm openly telling you that we worry about this future. And humanity, we should worry more about preparing for the future cold than anything else. And that's something we ought to consider. I'll finish up with just this view graph for basically showing you the sun going around with modern satellite. You got to put it up above the atmosphere, observe them in X-ray, and then you can see the sun spin around for, just in case you like sun like I do, I always watch the sun spinning around to watch this. If you have a video of sound, I would actually put this up. It's actually almost 100 days of the sun going around. Sun is very active now, by the way, going up again. A little bit. This is related to the 11-year cycle, not related to anything else. And I'll finish off by showing you this beautiful rendition of sunspot of 6 months. These are actually not real picture. This is a composite where the sun appears. Remember the butterfly diagram? Just want to show you where the location. Look, in the equator, almost there's nothing, no sunspot formed there. Then you need to know about Coriolis force. That's the thing, you got to learn a lot of things. And basically, that's it. Please, if you have any questions. Okay, we have about 5 minutes left, and anybody want to ask question? And then me and my son got to rush to go get a speaker for Alex Newman.
Just for folks that don't have any knowledge in any category to put up that are required knowledge, are there layman's books that touch on it in a way that folks like, let's say, slow folks like myself could, you did a great job, I understood everything you said, but I mean, is there a book?
There are quite a few books. The really good one, for example, is not mine. It's, people say that I don't write English, I write Chinglish, so my problem is that. Remember, I don't speak English, guys. Please, I learn English, but I don't speak English. I just, I just always dream about Shakespeare all night long. But I don't speak English. One of the good books is actually by my friend. Unfortunately, I have a field graph. It's by Douglas Hoyt. Look it up. Douglas Hoyt published a book by Oxford University Press in 1997 or 98, they published it. Or 2007. Mine was in 2003. By the way, send me an email. I have an electronic version because I'm not making money. I'll send it to you to read for free, of course. Please send to me. Yeah, email me. How do you reach me? Hold on. Did I put my email here? Yeah, right there. Willie at series-sign.com. By the way, I live now completely by people giving donation, $10, $5, whatever the money you can give me, I'll take, right? Got to feed the kid, But anyway, so yeah, please contact me through the email. And then please go to our website. Don't need the support, but there's all kinds of information. In fact, you can even find Benjamin just did a video. Because we published, a lot of paper. And it has to communicate to exactly what you say, to you guys to make sure you understand. I hope you are not only trying to understand, you are motivated, that maybe you can help answer some of the difficult questions. But Benjamin did a very nice video. We published a paper on snow extent over Northern Hemisphere. What the United Nations say. The United Nations say that all things will be just decreasing for spring and summer, but we show that, no, they're not telling you the whole truth. This is the problem. Every day, every single day, you hear half truth and half lies. Yeah. And then they always say that half truth and half lie add together will be full truth. Like half truth will be one truth, right? Absolutely a lie. This is the kind of nonsense that they're talking about. I used to put out equation, things like that. So, but anyway, no quiz today, too bad. But enjoy your day. Thank you very much.